Good day, my highly esteemed viewers. You are welcome back to my channel. Today's talk is going to be balancing of redox equation in alkaline medium. In our previous video, we talked about balancing of redox equation in acidic medium. The main difference between the acidic medium and the alkaline medium is the presence of the hydrogen ion in acidic medium, while in the alkaline medium there is hydroxide ion. Please, after watching this video, kindly press the like button and also subscribe. Is this your subscription that keeps this channel going and also encourages us? And don't forget, by the time you subscribe, any new video that comes into this channel will always get to you. Thank you and God bless you. Please, let's get started. As you can see, this is balancing of redox equation in alkaline medium. Let us use a typical example, a dichromate ion. This ionic forms is a typical example of a redox reaction where oxidation and reduction are taking place at the same time. To calculate this, like we said in the previous video, we said you use oxidation number method, in which case find the oxidation number of the various species that are taking place in the reaction. For oxygen, we don't need to do it because it doesn't have a partner. So let's see a simple method of finding the oxidation number of chromium. This call it X, oxygen is -2. S times 2 plus -2 times 7 equals this -2. 2s minus 14 equals -2. 2s equals -2 plus 14. 2s equals plus 12. S equals plus 12 over 2, which is plus 6. Hence, you have plus 6 here. This is the charge it carried, plus 2 is equivalent to it. This plus 3, and this plus 3 as well. Then let's link the ions that are similar. You can call it similar ions. You see, from plus 6 to plus 3, this is a reduction. So this is the reducing agent because a compound or element cannot reduce itself. Then we something reducing it. Then for this, you have plus 2 to plus 3, which is a form of increase and it's called oxidation or increase. So this is your oxidizing agent, is the one that add up to this. So you have this. In order to continue, you can separate the two oxidation half cell and reduction half cell equation. In which case, we can separate it and say oxidation, treat it separately, then later we join them. Oxidation half cell equation. So in the oxidation half cell equation, you bring the ion 2, will lead to the ion 3 ion. But not before you can form this positive charge of plus 3, you must have lost one electron. Fe2 plus gives you Fe3 plus a single electron. Call this equation 1 because it is balanced for this. Then for the reduction half cell equation, you can also bring the reactants CrO2O7 2 minus to give you 2CrO3 plus. So if you look at it, we have oxygen here, we don't have oxygen here. Because this reaction is taking place in an aqueous medium, therefore you can add water. You cannot add hydrogen. The amount of oxygen you have, you determine the amount of water you are going to add. You have 4 oxygen, you have 4 H2O. You have 10 oxygen, 10 H2O. But in this case, you have 7 oxygen. Now becomes CrO2O7 2 minus to give you 2CrO3 plus 7H2O. We already explained the reason. So here we can say oxygen is balanced. There are just 3 steps. Then, because you have introduced water here, you are affected the hydrogen. You have introduced hydrogen, therefore you must balance it here. And it will be in form of ions. That's the constant way of doing it. CrO2O7 2 minus plus 7 times 2. If it is 4H2O, 4 times 2. But in this case, 7H2O becomes 14H plus. This is the ionic form. 2CrO3 plus 7H2O. You see, hydrogen is balanced. Now, having balanced the hydrogen, the next one is the ions or electrons. So if you look at this, you have -2 here and you have +14. which gives you plus 12. If you bring this 2 times 3, which is plus 6, you bring this 6 to this side, become minus 6. You now have plus 6 remaining. So you write it including the electrons this time around. CR2O7 2 minus plus 14H plus 6 electron to give you 2CR3 plus 7H2O. That's what you now have. Now, if we have got to the stage, which is very, very important, because it's this stage that determine how we are determine the alkaline medium we are going to convert it into. So you have 14H plus, you have to add equivalent of this hydrogen ion in order to convert it to the hydroxyl ion. Let's say, for example, under acid, base, and salt, the dissociation, you have a H2O. If this one ionizes, it gives H plus OH minus. We know that. Then if you have 2H2O, the dissociation, when it ionizes, becomes 2H plus 2OH minus. So in which case we have 10H plus 10OH minus, it gives you 10H2O. Having that in our mind, we cannot change this one. We cannot add 14OH to both sides. Add 14 hydroxy ion to both sides. Don't forget, our target is to neutralize this and convert it to water. By neutralizing this, we now create OH minus in the opposite, in the other side. So you have a CR2O7 2 minus plus 14H plus 14OH minus plus 6 electron to give you 2CR3 plus 7H2O plus 14OH minus. It's not clear there, we can put it here, plus 14OH minus. Now, this one will not be changed to water. CR2O7 2 minus plus 14H2O plus 6 electron to give you 2CR3 plus 7H2O plus 14OH minus. By doing this or following this process, we have indirectly converted it from the acidic medium to the alkaline medium. But if you look at it again, you have water on both sides. So you can remove this water from this side. So we have water on just one side. So this one is removed from here. You now have CR, and remove from here too. CR2O7 2 minus plus 7H2O plus 6 electron to give you 2CR3 plus 14OH minus. So by having this now, we have gotten our equation 2. Can now call this one equation 2. So you now say multiply equation 1 by the coefficient of electron in equation 2 and multiply equation 2 by 1, which is also the coefficient of electron in equation 1. You see it. So you now use this 6. Multiply equation 1 by the coefficient of electron equation 2, which is 6, i.e. 6. So here you write i.e. 6, because that's 6 electron we have here. So you now use 6 to multiply equation 1. You can now have 6Fe 2 plus to give you 6Fe3 plus 6 electron. These electrons. Then the other one, since I'm multiplying by 1, just write it out. CR2O7 2 minus plus 7H2O plus 6 electron to give you 2CR3 plus 14H2O. Sorry, plus 14OH minus. 6 electrons, we cancel 6 electrons. Write every other thing out. But later you must cross-check. 6Fe2 plus CR2O7 2 minus plus 7H2O to give you 6Fe3 plus 2CR3 plus 14OH minus. This is supposed to be our answer, but we have to confirm it. If the right hand side is different from the left hand side of any ion or element, or group of atoms, then it is wrong. Let's bring out the elements individually and use atom count method. Fe, Cr, O, H, then ion. Use the demarcation line. Can repeat the same thing. Cr, O, H, ions. Now, iron here is 6, chromium is 2, oxygen is 7 plus 7, which is 14. That's this 7 plus this 7 molecules of water. Then for hydrogen, you have 7 times 2, 7 times 2, which is 14. Then for the ions, this side is 6 times 2, which is 12. This one is minus 2, I think, and that's just all, which is plus 12 minus 2, which is 10, plus 10. Then for this side, you have iron is 6, chromium is 2, oxygen is 14 OH, hydrogen is 14 as well. Then the ions, 6 times 3, 18 plus 2 times 3 is 6, which is 24. But here you have minus 14, which is 10. So you have everything balanced out. Remember, once you have completed your balancing, you may not be too sure until you have cross-checked it. If any of these ones on the left hand side is different from the one on the right hand side, it means there is an error along the line, in which case you have to go through them. So as I said earlier, this is a very simple method of balancing redox equation in alkaline medium. Alkaline medium means hydroxyl ion must be present, unlike the acidic medium, which means hydrogen ions is usually present. So that is the end of today's discussion. As I said before, kindly press the like button on this channel, and again, subscribe. God bless you, and we'll see you some other time.